Okay, so this is chapter 5, the data link layer. And like the chapters before, we're going to look at the principles behind the data link layer, kind of the theory, and we'll look at the instantiation and implementation, basically the practice. How do people really do this in real life? Um, some of the kind of core functionality that we're going to talk about is error detection and correction. How do we make sure that a packet gets sent correctly over one link? And how do we perhaps even correct the mistakes, the corruptions that have happened? Um, how do you share a channel? If you have one channel, like a wireless area that is going to be shared by a lot of different devices, they have to all talk in the same area. How do they share that effectively? Because if everybody talks at the same time, then nobody communicates. Talk about how link layer is addressed, and we'll talk about, we'll just hit again a little bit on reliable data transfer and flow control. These are services that the data link layer provides, but we already talked about them in terms of the transport layer. What's kind of interesting here is in a way, the data link layer is a lot like the transport layer. The transport layer is the transport layer for the application level. And the data link layer is sort of the transport layer for the network level. Yeah. All right, so let's jump into this and see what we can learn. You recall this from before. We have nodes in the network. Nodes might be hosts or routers, and there are links between those. And these links are point-to-point kind of connection. All right, so we're way below the transport layer. Now all we're concerned about, right, the two endpoints are always going to be point-to-point connections, right? We're not going to have multiple hops in between them. A frame is what we call a layer 2 packet, and that is going to encapsulate a datagram, right?
What? A layer 2 packet?
A layer 2. Layer 2 is the link layer, layer 3 is the network layer. Yeah. It's another way of saying it's a link layer packet is a frame. We've had this on all the quizzes, so you know what I'm saying. That's our word that we should be using. What is the goal of the link layer? What's the goal? All right, so this is high level, right? What is the whole goal? What's the point of this whole chapter? The point is we need to transfer a datagram from one node to an adjacent node over a link. That's pretty simple, but we're going from point A to point B, where A and B are adjacent to each other, and we want to successfully, correctly deliver the frame from point A to point B. All right, so we're just looking at that one adjacent connection, that one hop, and that's what the link layer is all about. So if you remember our analogy we talked about a couple weeks ago, a couple chapters ago, you remember, imagine that we were actually taking a trip from Henderson to New York. And we could imagine that because we are as cool as we are going to take a limo from Henderson to Nashville. Yeah. In Nashville, we're going to get on a plane to go to New York. And once we get up to New York, we're going to take a train to somewhere where we're then going to take a taxi to somewhere else. All right. So in this case, we could imagine that we, the tourists, are datagrams. Each transport segment is like a communication link. That is from Henderson to Nashville. That's a communication transport segment. From Nashville to the New York airport, that's a link. The train ride, that area is the link, so forth. The transport mode, the way we got there, that is the limo, the plane, the train, the taxi, that is the link layer protocol. How do we move on this particular link? And you can see over the whole trip, which is sort of like the transport layer, or we could see that as the network layer as well, right? The routing over multiple decision points, multiple routes. That is our Um, that's our network layer. Maybe we have a travel agent that set this up for us, and the travel agent is kind of like the routing algorithm. That analogy kind of makes sense. So what we're talking about is over this multi-hop trip, it's possible that we could be sent over different link layer protocols. But that's okay, right? As long as we get the core data, which is us, the tourist, from this endpoint to the other endpoint. So we might have different protocols for different links, and those links might provide different services. So it might be the case that some link layer protocols provide a high level of reliability, so packets are almost, or frames are almost never lost on these kind of links, whereas other link layer protocols, like a wireless link layer protocol, may be really bad about reliability and may lose a lot of packets because of the nature of the medium and the nature of the protocol. We would hope then, if one of our links is very lossy, what's the solution for that? How do we actually get from one endpoint to the other endpoint? How could we get this packet across the whole route if we have one link that loses a lot of packets because of its link layer? What are we going to fall back on and depend on?
Another link?
Maybe. Or we might have to fall back on the transport layer, like TCP, where TCP is going to have to resend the whole packet over the whole pack. Does that make sense? So, I mean, keep in your mind the context of this, that really this is happening inside of a datagram, which is happening inside of a segment, right? Inside the network layer, inside the transport layer. Okay, so this is a pretty long list. I know this is a lot of words, I'm sorry. A list of services that link layers provide. Number one, they do framing and link access. This means we have to encapsulate a datagram into a frame. We have to add a header and a trailer so that, additional information. We might have to access the link in a special way. If it's a shared link, like I mentioned, if it's a wireless link and only one person can be talking at once, then the link layer is going to provide a service called Media Access Control, MAC. Right? You've heard of a MAC address, and the MAC address is connected to this, where MAC addresses are used in frame headers to identify the source and destination of the link layer source and destination, and that's different from the IP address. Secondly, if most likely the link layer is going to provide reliability. So if we want the link layer to reliably deliver packets, many link layers do this, and they're going to have to do the things that we talked about in those RDT protocols. You remember the NACs, the ACs, the sequence numbers, that kind of stuff, to make sure the packets actually get through, the timeouts, those sorts of things. A question that the author brings up is, why do we need link level and transport level reliability? As I already mentioned, right, if we lose this frame and a frame contains a segment, TCP is going to recover from that. TCP is going to resend the segment, right? Because it'll detect when the timeout goes off that segment was lost, it didn't get an ACK for it, it'll resend it. So why do reliability at both levels?
Faster.
Faster? Yes. Why? How?
Because TCP is going to resend the whole packet, whereas the link layer will just resend whatever datagram or whatever frame. Would it be a datagram or frame? Whichever one.
It's going to send a datagram in a frame.
Right.
So that would definitely be the case if we had to fragment a segment into multiple datagrams. If the segment fit in one datagram, then that reason wouldn't be the case. But there's another issue.
Just the complexity.
Okay, if we think about this is more complex. If we have this one link that keeps dropping, imagine that's the last link in the path of a multi-hop path.
Oh,
TCP is going to have to go from all the way to the original sender, and all those other guys are going to have to waste their bandwidth kind of, again, getting it there. So it's kind of more efficient to do reliability at the network layer so that TCP doesn't have to do an end-to-end retransmission. We might can just do this resubmission between two links. Does that make sense? The link layer is also going to do stuff like flow control, which is a speed matching service between sender and receiver, just like TCP. It may do error detection, which means we're going to detect errors that are caused by noise or signal loss between the two links, and ask the sender to retransmit a frame that's been corrupted or dropped. Error correction is kind of a stronger, it's kind of taking the next step after error detection. With error correction, the receiver identifies and corrects bit errors without requiring the whole frame to be retransmitted. That may seem a little magical if you think about it, but the way it works makes sense. Is if you send enough redundant information in the packet, then you might be able to determine what the message really was. You could imagine a very simple, inefficient way of doing this would be to send the data twice in every packet, duplicated. So if the first one got corrupted, you'd have the second one. Yeah, maybe. But then how would you know which one is right? We're going to do much smarter ways than that. Another service that the link layer may provide is this half duplex versus full duplex. Half duplex, what does that mean? Did y'all read? You know this? Half duplex means you can send. Half duplex means that nodes at both ends of the link can transmit, but not at the same time. So full duplex means you can send either direction simultaneously. Half duplex, you can only send one direction at a time, but you can send both directions. Does that make sense? All right. Where is the link layer implemented? This is a good question. So let's think about, in our previous chapters, we've talked about the application layer, which is definitely implemented in software, probably in an application. We talked about the transport layer, which is implemented typically by your operating system. We talked about the network layer, that's implemented by the operating system of a computer, also, I guess, the operating system of a router, or almost the firmware. So that's probably the hardware of a router. The link layer is implemented primarily in your network interface card, that adapter, right, the NIC. So if you've got an Ethernet card or a wireless card in your computer, that's where the link layer is really happening. However, there is I guess a piece of this that is implemented in software as well, because you can configure your MAC address if you really want to. But for the most part, link layer is going to be implemented in hardware, a little bit of software, and in some firmware, where firmware is kind of in between hardware and software, firmware on your card. So you can kind of see how this breaks down in the sense that the link layer is in software and in hardware. All right, how do these two adapters communicate over a link? We know that we're going to have a datagram that's passed from IP in software. It's passed down to this controller, which is the link layer controller. It's going to encapsulate it in a frame and then send that over the link. It will also add the error checking bits. It'll implement the reliable data transfer protocol, the flow control protocols, and so forth to communicate between the sender and the receiver. On the receiving side, it's going to check for errors using those extra bits that were added. It's going to do the other part of the reliable data transfer, which might involve sending acknowledgments or asking for retransmissions or those kinds of things. Implement flow control as well. Well, it'll extract the datagram when it has received a correct one and then pass the datagram up to the IP layer, the network layer.